Good evening. Good evening, participants, and good evening, sir.
Good evening. Good evening.
To all to this fourth day of faculty development program on advancements in sustainable energy management and environmental protection. So today's speaker for this session one is Professor Ramakarja. It's my privilege to introduce our distinguished speaker, Professor Ramakarja, a highly accomplished academician and researcher in the field of civil engineering. Professor Jha is currently serving as a professor in Department of Civil Engineering at National Institute of Technology, NIT Patna, with a PhD in civil engineering, specializing in water resources from IIT Roorkee. Professor Jha has over 28 years of rich experience in academia, research, and administration. He has guided numerous PhD scholars, BTech and MTech students, and has made significant contributions to water resource management, climate change impact analysis, flood and drought management, and environmental flow assessments. Professor Jha's achievements are numerous, including 7 prestigious awards at both national and international levels. He has successfully led over 26 major projects, published around 200 research papers, authored international book chapters, and established advanced laboratories in remote sensing and GIS. His role as a consultant for globally renowned organizations such as UNESCO, World Bank, and the European Union highlights his expertise on an international platform. In addition to his research, Professor Jha has played a pivotal role in curriculum development, administrative leadership, and mentoring faculty and students. Today, Professor Jha will be sharing his insights and expertise on climate change and energy management, which I'm sure will be both enlightening and inspiring for all of us. Now I welcome Professor Jha to take over the session.
Thank you. Thank you, Fatima, for giving a very big introduction of mine.
Welcome.
Thank you so much. And dear participants, I'm Professor Jha from NIT Patna. And now I will share my presentation. Let's see. Are you able to see the presentation?
Yes, sir.
Okay, good. So, yes, so this is a training program, and this is a very good topic which is given to me is climate change and energy management. There are two things. And before I start my talk, I always show one slide, and this is about, you all know this man. Do you know them? Do you know him?
Yes, sir.
Yes, sir.
Stephen Hawking. And you know, he is in the wheelchair. Today's Einstein. He has done a lot of research on black hole. I have two questions to you. Do you know his father? Answer will be no. If I ask, do you know his teacher? Answer will be no. Same is with the APJ Abdul Kalam sir. We don't know the father. We don't know their teachers. So, dear participants, people will know you. People will know you. You are doing for yourself only. Yes, your parents, your teachers are in your heart. But people will know you. So whatever courses are going on, whatever courses you are studying, FDP courses you are attending, this is your life because people will know you. So you are doing for yourself and only for yourself. Whatever you are doing, please do it sincerely, honestly, so you will flourish in your life. Second thing, that was one thing, that people will know you. You are doing for yourself. So this is your life, make it best. Second thing, what is great in him? Dr. Stephen Hawking, what is great? He is not able to walk, he is not able to talk, he is not able to do things. What's great? mind, brain, preserve it, protect it, head, your head of the family, head of the department, head of the institute, head of the country, and your head is very important, right? So protect it. All the five senses we do have, all the five senses are here only. Eyes, nose, ear, tongue, skin, all five are here. Head area is very important. Protect it. Okay, so these were the two messages before I start any talk I give to my students, my faculties, youngsters, that this is your life and protect your head. Right now, we have topic on climate change and energy management. So let's talk separately. First one is the climate change. What is change? What is climate change? What is the difference between the climate change and climate variability? You know, change is permanent. Change is permanent. What you were looking 5 years back, you are not the same. And after 5 years, you will not be the same. That is a change. Change is permanent. Climate change, temperature rise, rainfall increasing, rainfall decreasing, weather is changing, and if it is changing continuously. Another example I'll give you. Variability, climate variability. Suppose you wake up early in the morning. I know many of you don't, but I suppose that you wake up in the morning at 5:30. But you don't wake up every day at the same time. Sometimes 5 minutes before, sometimes 5 minutes afterwards. So this is a day-to-day variation. On an average, you are waking up at 5:30. That is climate variability. If today it is raining, tomorrow it is not raining, it is not the climate change. It's climate variability. So be careful when we are talking about the climate change and climate variability. In 1 year, we may see a lot of climate variability, but change is a long duration activity. And here you see it defines that change is refers to long-term shift in temperatures and weather patterns. It may be a rainfall, it may be a wind, it may be a humidity, it may be temperature and other weather parameters. Right? It's very important for us to differentiate between the climate change and climate variability. It is a natural phenomenon. As I told you, what I was looking 10 years back, 20 years back, when I was child and when I'll be old guy, it's totally natural phenomena. Natural decay process, natural upgrading process. These are all phases of life, natural. But nature, the hilly areas, the rivers, the nature, the flowers, the ground, everything is very beautiful. Groundwater, surface water, beautiful. But it will decay with time. It will get older. It will have a weathering effect. Air, rain, high temperature, everything is going to affect our skin, our body, all the living things. That's a natural process. Moreover, what we are doing, we have some anthropogenic activities, human interventions. We are giving human interventions, and that is creating problem. That is adding, means what? A child, a man, human being grows up and becomes old. It's a natural process. But two children, one is living on the street, one is living in air conditioning, and one is living in normal house. They all will, with the same age, will look different. Right? Because they have anthropogenic impact of the system. They are not getting good food, their hygiene is not good, and so many things. They look much older who are having the good hygiene, good food, and good environment. So that is anthropogenic activity. So whenever we are talking about the change, climate change, it is natural as well as the human interventions, which we call it anthropogenic activities. Right? Now, let's get into details. Human activities. What really activities we do? We do agriculture, we do industry, we do the transportation, we do the heating, we do the fossil fuel burning. All these things are because now in winter in Patna, in Bihar, we have a lot of cold. So you go outside and people are burning the woods, coals, and that is the fossil fuel. We are burning it. So these are the human activity. And if I say human activity, what happens? We are releasing carbon dioxide in the atmosphere. We are releasing methane in the atmosphere. And in winter, many people use the heaters, blowers in their room, and the room is closed from all the sides. What happens? Because of this human activity, because of the heating, what really we are doing? We are killing the oxygen, and that transforms into carbon dioxide. And further, because carbon dioxide is having CO2, two oxygen contents. So what really it happens with time? It transforms into carbon monoxide, CO, and people die in the room because of the lack of the oxygen in the room and because of the human activities. So this is in a longer term, if I will say this is a climate change process. And another one is land use, land cover changes. How we are making the land use, land cover changes? We are having a lot of urbanization. So for urbanization, we are reducing agricultural area. We are reducing the forest area. So we are doing deforestation. We are really impervious surface because urbanization, we will construct road, we will construct buildings, we will do so many things like that. It means what really we are doing? We are playing with the nature. We are changing the land use, land cover pattern. And as a result, what really we are doing? We are becoming carbon poor country. Carbon rich country we are not. We are reducing the plants, we are reducing the coal, we are reducing the natural resources. So that is causing greenhouse effect. And we will see that also, what is really greenhouse effect. In the coming slides, we will see, because it is very important for you to understand the climate change, climate variability, human activities, which is causing climate change processes. And once it is done, it is really creating carbon dioxide, carbon monoxide, and other greenhouse gases. Because we are more advanced, we want to go for urbanization and compare ourselves with developed countries. But we are really not looking for the carbon, prevention of the carbon, means plants, trees, right? Now, climate change, once we saw climate change processes, what happens then? Greenhouse gases, what it is doing? You are finding these are the different characteristics. We are finding that ice is melting. What really we are finding? Average temperature is rising. Precipitation pattern is changing. Rainfall pattern is changing. Earlier, I remember during our childhood, we used to find that the rainfall is spreading over the 2 months, 3 months, 4 months. For 1 week, for longer duration, we were not able to see the sun. But now, the precipitation rainfall is like that, like a Zomato and a Swiggy. It comes, it gives you delivery, and it goes back. It is just like that only. It is raining, coming, raining, intense rain, and it goes. We don't know from where clouds came and how it rained, and it is going back. So it is just like becoming a modern, as we are changing our behavior, as we are changing our day-to-day habit, as we are more fond of fast food, the nature is also changing. Precipitation is coming as a Zomato or Amazon and giving you a delivery, and raining and going back, right? So change in precipitation pattern. Clouds, they are changing. Ocean circulation, it is also changing. We say that we are going to have water scarcity. Why? Why we say the water scarcity? We have water. Then why we say? We have a lot of water in the ocean. It will go to the groundwater. It will evaporate. It will rain. It will again come to us. It will go to the ground. It will go again to the sea. So it is a circulation. Then how we say that water in Hyderabad, there is no water in the Deccan Plateau? Why we say that? Because we have changed the cyclic pattern. We are exploiting more. If I am getting a salary, I am knowing that I am going to spend 20,000, 30,000, 40,000. Next month again it will come. It will follow a cyclic pattern. But if it becomes abrupt, it becomes irregular, then we have scarcity, because we are withdrawing more money than what is going to bank account. That is the problem. That is the main issue we are finding with the change in precipitation, ocean circulation, and abrupt climate change. That is causing abrupt climate change. Every water is going to sea. River is flowing with fresh water. A lot of ponds are there. A lot of wells are there. They are having the water. And when it goes to the ocean, it becomes saline. So everything is changing. Water, even water temperature is also. So from human interventions, we are finding greenhouse gases as a result. And from greenhouse gases, we are finding this is the total changes. Same is applicable to human being also. If you eat, if you are not taking care of the head part, you are eating something bad, then it will have effect on your stomach. If we lose 60% of our energy through our eyes, whatever we like, we just try to see it closely. We 60 to 70% of our energy we are losing through our eyes, and that will affect our brain. That will affect our food habit, because if you are doing a lot of work, all the blood comes to your brain and stomach indigestion starts. So human activities is causing problem in the full body system. Same is with the climate change. When we are talking like this, so then what is the threat? I will have problem. I will have corona issue. I will have HMPV virus has come recently, and so many health diseases. First is stomach is upset. 90% of us are having stomach problem. Why? Because we are not taking care of this head. We are giving human activities, taking whatever we like, our taste, and that is creating whole problem. Blood pressure, then we have the sugar, we have the knee problem, back pain, stomach problem, kidney problem, and blah, 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 so many things. So these are the threats. When we talk of the climate, these are the threats in the climate. What? Sea level rise. Many places, many cities are going to vanish and they will go inside the sea. Disaster spread means lot of casualties, lot of hazardous famine, lot of economic losses. These are different type of disasters. Loss of traditional livelihood and biodiversity. Everything is going to change. Everything is going to change if there is a climate change. And if we are not careful, each of us are equally responsible. As everyone is responsible for their health, now I'm finding many participants here, 60, 70. Each one of you are responsible for your health. If you make any human interventions, any human activity which is not natural and which is going against your health, good health, you will have to face it. Maybe some of you are having some issues. So when we combine this is, I showed you from a human intervention here, then human activities to climate change processes, and then from their main climate characteristics, and finally major threats. It's very important for all of us to be awake. Each of us are equally responsible, and we have to make proper mechanism, management to reduce this climate change variability. Some examples I have shown you here. And I will give you one example also, which we have done in our institute in recent past. Here you see floods, especially in the northern part of India. You can see Bihar, Bengal, Odisha, Maharashtra, Gujarat. They are facing a lot of flood problems these days. Even Rajasthan has started facing this problem. Many casualties. And this is not only a problem of flood. We find that when the flood recedes or water remains over there, lot of health issues, medical issues are coming up. Same is with the drought. What is the difference in flood and drought? If there is a climate change, as I told you, suddenly rainfall is coming, huge amount of water is coming, and we call it cloud burst. In hilly area, if the cloud burst is there, what happens? If there is a cloud burst in hilly area, water comes with the lot of sediment. Very simple thing I want to tell you. If an elephant is falling from the hilltop, and if a mouse is falling from the hilltop, if an elephant is falling from the hilltop and a mouse is falling from the hilltop, which is going to give more impact? Of course, elephant. Why? Because it is having mass into velocity. Both are coming with the same velocity from the hilltop. But elephant will give you more impact because it is not having only mass into velocity momentum. It is having mass into velocity per unit time, mass into acceleration, that is force. And that force of elephant is going to vanish everything. When there is a flood, and flood is because of the cloud burst, huge rainfall, which is coming, and that is coming on the earth in the hilly area, and the water starts flowing, it will take lot of sediment with it. And it will not have only momentum effect, mass into velocity, but it will have mass into velocity per unit time, that is mass into acceleration, that is force. And that will vanish everything. Many villages vanishes because muddy water is coming. It's not only flood water. That is the problem. We have to understand the fundamentals. Head should be strong. Make your head very strong. This is your life. People will know you. Then comes the drought. That is also because of the climate change. And this drought comes very slowly. Like food poison. Like we eat every day, we are eating fast food, junk food every day because we don't have time. And if we don't have time, we go to the market, we buy and we eat. I don't know what we are eating, whether it is 2 days old, 3 days old. When we come to know? After next morning. When we come to know? At midnight. When we are feeling uncomfortable, feverish, vomiting, loose motions, everything. Drought is like that. Immediately we will not have any. Immediately it looks very good. Oh, drought. But it comes after 10 days, 15 days. No rain, no rain, no rain, no water, nothing, nothing. It is getting dry because of the climate change. And result comes after 15 days. Same is with us. Nowadays, we are more concerned for time, no time. I have no time, no time, and like that. And that is a drought. So you should be very thorough. You should understand the fundamentals. Don't mug up the equations. No. You must understand what the change is, what the climate variability is, what really we are talking about the floods, what really we mean by floods. Very simple example I'll give you, then I'll come to this slide. Flood. I'm hungry in the morning. I wake up, I am hungry in the morning. I eat a lot, right? I am eating a lot. Then in the daytime, I go to office, I took my lunch, I take it, but some students came, sir, I have brought this samosa or this idli and vada way for you. I will eat it. Then suddenly after at 4 o'clock, someone came, sir, this is a very, I prepared at home dosa. You please have it. I ate it. And like that, I ate, and tea and drinks and coconut and then everything I have started taking. What will happen to me? In the evening, I will have two situations. One is I will vomit. The second one is my stomach will be upset. So if I vomit, that is flooding. The soil is hungry. In Hyderabad, soil is hungry. In the monsoon, when the first monsoon comes, it will take breakfast, everything go in. Then in the afternoon, everything will go in. As soon as July, August comes in, little rain will cause flooding because the stomach of the soil is full. The stomach of the soil is full means it is flooding. And if it is flooding, it will create hue and cry. Anywhere in the world, globally, you go and see when the flood comes. It will be in August, September, or October. Yes, please. Anybody wants to know anything? Is it okay?
No, sir, please continue.
Okay, fine. So that is the thing. You have to understand what the flood is. And soil is hungry, soil is full of a stomach, and then it is vomiting, and that is flood. Similarly, snow melt. Today, I may not be able to show you one slide, but it is showing that the glaciers are melting. The snow is reducing. Sea level is rising. Temperature is increasing. I see they say that temperature is increasing by 0.5 degrees, 0.3 degrees. Why? What is the meaning? 3 degrees, 0.3 degrees, it has no meaning. It has. Why? Because we are talking of the extremes. If temperature is 1 degree and it becomes 0, you will find ice. If the temperature is 49 degree, it becomes 50 degree, it will be burning. When each of you, many of you might be making tea at home, right? I also do it in the morning. I make tea. Now, as soon as the water boils, starts getting heated and then boiling, what happens? Its temperature goes up to 50, then what happens? Oxygen reduces, water evaporates. Yes, that is the impact of climate change, temperature. We are talking of the peak values, maximum values. You take example, every day you are doing it, making tea, you are going to tea shop and he is making tea or she is making tea. You are observing it. As soon as it boils, oxygen gets reduced. High temperature, oxygen will be less. You will find lot of evaporation. Hot water is coming out. Everything is climate change. You think that the teapot and the water is the nature, is the hilly area, is the snow area. And if the temperature rises there, same situation will be there. Okay? So that is the importance. Fundamentally, if you are clear, if you understand this with the human analogy, what happens to my body system, how it behaves, and what is the nature, then you will not have any issue. And then you remember the equations and go and appear in the exam and you will do wonderful. But if you are not fundamentally clear and you are mugging up, then you will not. Now you can see here in India also, rising mean sea level because of the climate change. This situation may take place if we are not careful. Right? And this is the temperature. Over last century, how it has been increasing. The temperature has been going up in the last century. Now comes the global climate change over the last century, and this is showing some numerical values, and this is not done by me, this someone has done it and I am reporting only. But this is an information. This information may be of help to you when you are planning for the city, you are planning for your campus, you are planning for your home, and you are planning for the society. You have to know this information as a background information, right? So this is showing that how the temperature is increasing and how it has been changing with time. Some graph is shown over here. You see here, it is increasing. Line is showing increase, but you see each bar chart, it is showing sometimes up, sometimes less, sometimes more. So that is a variability. But the trend is long term, right? What I wanted to tell you, the change and the variability, I think you have understood. And this whole area, you will see this, that how the temperature has been varying at different places, less and more, and which are having the red signal. It is indicating what it indicates. It is giving you the temperature and the rainfall pattern of the all over India. You can see here, this is also showing you the, now we have to predict, we have to go for modeling, because we have talked so much about the climate change, variability, and then the greenhouse gases, how, what is the cycle and how it is going to affect. And I gave you example of the human analogy, how we behave. I give you example of it, making a tea. Now, future 2030, 2040, 2050, what we are going to have. We have to predict it. We have to see what temperature will be approximately after 50 years, 20 years, 30 years. Rainfall, what will be the rainfall after 20 years, 30 years? Why? What will happen to your children? What will happen to your grandchildren's if you are not thinking so? And if you are not giving answer to this, why? I tell you all 60, 70, how many participants you are and the organizers. Let's all go to a hotel in Hyderabad sometimes when I am there, and we all will eat for 2 days. Whatever you want, you eat. Vegetarian, non-vegetarian. But I will not give you water to drink. Whatever you want to eat, you eat. I will not give water to drink. Also, I will not give you water to wash your hands. Use tissue paper, use milk, use oil, use juice, use dal ka pani, use sabji ka pani, use whatever you want, liquid you want to use. But I will not give you water to wash your hand and not give you water to drink. What will happen? This is the importance of water. What will happen to your next generation, your children, your grandchildren? For that, we have to go for futuristic analysis, modeling, and there are many global circulation models. What is a model? It is not that model what we are seeing in the movies and all the fashion shows. Modeling is for prediction. What is model? Model y is equal to mx plus c. Is a very simply straight line equation. Y is equal to mx plus c. Each of you have done it. Y is dependent, x is independent, m is the slope, and c is the coefficient. Intercept, we call it, right? If c is 0, it becomes y is equal to mx. M is the slope, x is independent, and y is dependent. Now, this is a very simple linear model. We want to represent something independent with the something dependent, right? So that is very important. We have so many general circulation models available globally. Now it is available. Every scientist is using. Many of you are also doing on climate change model, and you are downloading, downscaling, and using it, and blah blah blah. So many things you are doing it and predicting. But which one is most suitable for India? Which one model is most suitable for our region? Andhra Pradesh, Telangana, which one is more reasonable method? What really you will do? You will use the observed value, what is being observed, temperature daily variation, and the rainfall daily variation, and then you will compare with the different models available for India and for Telangana and Andhra Pradesh. You will try to compare that. Okay, this model is giving this kind of trend, actually observed values during that period. Then this model is giving this kind of result. My observed values are like this. Okay, the out of 13 or 14 or 100 models, these 2-3 models are most suitable for our study area, and I will do the future projections using that. This is what we also did for our study. I'll show you. Yes. When we talk of the general circulation models, we have so many things to consider. It considers there are satellite data and they are taking every day, every minute, and they are doing it. There are different models which are available, around 40 models. Many big scientists who are basically physics background, and they are using the physical laws of the nature. You will ask me, what is the physical law of the nature? How you walk. We walk by Newton's third law. Every action has its equal and opposite reaction. We walk fast, run fast. We try to push the earth very fast. You might have seen the fan. Always it is rotating like this, ceiling fan. Why it is not changing its direction whenever I do it? Why? You all have studied that. Why fan whenever I'm putting, if I put a ladder, it will stop and again I start, it will rotate like this only. Means anti-clockwise. If you just put it this way, you will find it is anti-clockwise. Why? You all have studied Fleming's left hand rule. Current from top to bottom, left to right is the magnetic field and the direction of flow. Right? So we are governed by the law of the nature. And the physics people might have used different natural phenomena, climate, wind speed, temperature, and so on. Okay, some children is there. Please switch off your, mute your mobile, this speaker. So now there are different models, right? And these models, we have to apply for Indian condition. We did it for, and then they are having this, you go through that, there what is SSP, what is RCPs, when we are using the climate models. And you can apply these data for Indian conditions, which we did, and we found that 13 climate sensitive models are very useful for India, for whole India. You can also try one of these models for Telangana and the Andhra Pradesh and Tamil Nadu and the neighboring states, everywhere, all over India. You belong to which place, because charity starts at home. So you can start over there and you can do a lot of work. You can find out of these models, all these 13 models are suitable. They are bias corrected and they are suitable to assess the climate change and future projections. So out of these 13, you can find that which one is giving me the best result, and then you can do the future projection. We also did for this region, the northern region, and we found that these are the results. Just I wanted to show you, these are the results, and we can really do the future projection. You see here, mean rainfall, how it is going. It is showing that in 2099, 2075, 2078, it is going to increase. Trend is increasing. It may have the variability annual, but trend is going to increase. Rainfall is going to increase. You can see here. It is going to mean monthly rainfall is going to increase. Annual rainfall is going to increase. Similarly, here you see that how it is going to projected one. So with that, I can plan for Telangana. I can plan for Andhra Pradesh, I can plan for Tamil Nadu, I can plan for Karnataka, I can plan for any place based on this, that what should be the planning to save living things, including human, livestock, and the plants. Based on this information, rainfall, temperature, wind speed, everything we can do the calculation, and we can plan storage, storage phenomena, how really we can do it. Maximum rainfall is also going to increase. So as I told you, it is just delivering like a Swiggy or the Amazon and going back. So maximum rainfall is also going to increase, right? So we have to really make proper arrangement for its storage, water storage, because that is, as I give you example, we all can go to hotel, but you will not be given water to drink. You will not given be water to wash your hands. Use anything you want, juice, oil, milk, anything you want, tissue paper, but water will not be given. This is the importance. Now, greenhouse effect, as I told you, we have done a lot of work on greenhouse effect. I have been teaching this course to my students. Greenhouse gases are very important, and it is coming out from the air conditions, it is coming out from the cars, it is coming out from the fossil fuel burning, it is coming out from the this from the reservoirs, water storage, methane is coming out, all these toxic gases are coming out, and they are going to the atmosphere. What they are doing? They are making hole in the ozone layer. What they are doing? They are making hole in the ozone layer. Means what? You see that in the summer, in the hot weather, if I keep my car outside, what happens? In the daytime, when you open the car, it is a burning. It is just like burning. What happens? The short wave radiations which are coming here are transformed to long wave radiations, and it is moving inside the car only. It is moving inside the car only, and it is becoming a thermal effect. It is giving you very heat island. It is just behaving like a heat island. That is greenhouse effect. And you please observe, during cloudy day, it is warmer because of the greenhouse effect. Why? Going up and coming back. Short wave radiations have penetrated. It has come to Earth. It is going back, but it is transformed into long wave radiations. And then it is keep on moving here up and down because of the clouds, because of the greenhouse gases, because of the pollution. A lot of pollution is in Delhi. You are listening every day. Huge amount of pollution. It is smog, lot of itching in the eyes. Why? Short wave radiations are transformed into long wave radiations, and we are getting greenhouse gas effect. It also makes hole in the ozone layer. And in many countries, you are finding, because of the greenhouse gases which are making hole in the ozone layer, is causing cancer. Because nature is beautiful. Nature is wonderful. Why? Many rays which are harmful, X-rays, alpha, beta, gamma, ultraviolet, nature is not allowing that to come to Earth. If you study the remote sensing and GIS subject, you will find the nature is not allowing many rays to radiations to come to Earth, and ultraviolet rays are one of them. But because of this greenhouse gases, if there is a hole in the ozone layer, ultraviolet rays will penetrate and will come to to Earth, and that will cause the cancer, skin cancer. That is why in summer we say our students, our faculties, please don't go out, don't live in the sun for longer duration. It will not only make your skin black, tinting, but it will also create skin cancer. It may create skin cancer. If there is a hole in the ozone layer, ultraviolet rays are coming to the earth and you are getting affected with that rays, it may cause skin cancer. So be careful, right? This is the greenhouse gases and we have to reduce it. When we will talk about the energy efficiency, there I will tell you some of the things. Really, we have to reduce the greenhouse gases. And how can we reduce it? That we will see over there. It's very important. It's really very important for all of us. If we want to save ourselves, we have to do it. It is coming up and going up. It is coming down and going up. It is absorbing and radiating. You know, the dark color, black color, we always say in summer we should wear light color. We should not wear dark color. You see buffaloes, you see the black color things. What happens? In our home also, we are using iron pan, right? For making roti. We are using iron pan for making sabji. Why? Because it absorbs, and when there is no flame in the gas, it radiates. That's why we find that our food is preserved for longer duration over there. It remains heated over there. It remains warm over there for longer duration because it radiates. So black color, that's why we are finding that we are using black iron pan, right, for cooking. And black color absorbs and then later on radiates, right? So greenhouse in the Andhra Pradesh, you might have seen in Hyderabad now, in the Telangana, we are observing lot of fishes. NRSC, National Remote Sensing Center, what they do, they forecast the fishermen at 4 o'clock in the morning that sea surface temperature will be like this, and fishes are found at a particular location at a particular temperature. All the fishermen are going, and all over India fishes are coming from that area only, Andhra Pradesh, Telangana only. You will find everywhere this Andhra fish, everywhere you will find. This is because the temperature is sea temperature at particular temperature fishes are observed, and satellite data is giving you the value because of the radiation. Why I'm telling you all this example? Radiation. At night it radiates. There is no sunlight and it radiates. That's why they forecast in the morning. They take the surface temperature in the absence of sunlight from the remote sensing and they give you the values. Now, we have this theory. I will not tell you because these are so many things. We have mean constituents, atmosphere and how they are behaving. This part I will skip because this is a important greenhouse gases. So you can see here, and then comes how it behaves, carbon dioxide, methane, N2O, and sulfur dioxide, how it is behaving. It is giving a different, this presentation I will send, and any of you want more about the greenhouse gases, because I have some more things to tell you about the aerosol and then finally energy efficiency. So I will skip this. These are the greenhouse gases, different how they are affecting these equations, what is the climate forcing, everything is explained here. That is not, they're not required. But why certain gases interact with radiation, like methane, water, CO2? What happens? When there is a radiation coming up, it can excite the molecule either by vibrating or rotating. Molecules of a particular kind of gas have different shape so that they vibrate and create lot of issues with the human being, with the atmosphere. And this you can see here, example is given. So I will not explain this as well. You can very well see it. Now this is the thermal structure of the atmosphere. You can see that how the thermosphere, mesosphere, stratosphere, and troposphere is changing as we go up altitude. And as we go to the hilly areas, you can go to Tibet and any other places, Himalayas, you will find lack of oxygen over there. So different atmospheric pressure is there, and the pressure is working on the atmosphere and in our body, human body also. That is really causing the climate change. This I have already explained you. Now, physical impacts. So it has a different physical impact on climate change. We already discussed everything about this. Social impacts of the food system, health, water resources, migration. You know, in desert, Sahara desert, people migrated because of the climate change. Temperature has gone extreme value, 49 to 50, 50 to 51, 51 to 52. No one can live over there. So they have to move. Aerosols, they are again very important. You know, you are using deodorant, that is aerosol. It is having oxygen, it is having nitrogen oxides, ammonia, organic compounds. So that is aerosol we are using in our deodorant. That is also in the atmosphere, and that is helping to reduce the greenhouse gases. We are having this aerosols in the atmosphere also. So we should be really working on having more aerosols and less greenhouse effect. What will happen? That will reduce the impact, and it will reduce the hole in the ozone layer. This again you can study in your remote sensing when you are doing it, how small particles and different kind of scattering is taking place in the atmosphere, and how useful aerosols are. And I give you example of the aerosol is a deodorant. Ozone layer, O2, O3, sun, because of the sun, it is a cyclic O2 and O3. And we have to have more ozone layers in the atmosphere if we want to protect us from the ultraviolet rays, X-rays, alpha, beta, gamma rays, because that is very dangerous for human being and all living things. So ozone layer is very important. And remember, now when we talked about the climate change, we discussed about the climate change. We have seen the global circulation models. We have seen the greenhouse gases. We have seen the aerosols. And now we are saying that if we want to protect the climate change, we have to have more ozone layer, so that it less greenhouse gases, more aerosols, and maximum ozone layer over there. Ultraviolet light, I told you in the remote sensing, you will study, you will see that nature is protecting us. Nature is beautiful, it is wonderful, and it is protecting us from the UV rays. Nature is having the layer of the in the atmosphere. Now, after doing this, we found that when I was talking about the climate change and its components, the energy management is really very important. We are least bothered, and you will find when the winter starts in Delhi, people start talking about the parali, burning of fossil fuels, burning of the paralis, means husk. This stem we are finding from the rice, they are burning it, and that is creating a lot of problem. So energy management is very important. We have to be carbon rich country, and that is possible if we are doing energy management. That will save really climate and save our life, our next generation. Like I gave you example of the water, it is very important. Now what really we have to do? Reduce fossil fuels. It means we have to reduce the burning of fossil fuels. We have to go more on renewable source of energy, solar system, hydropower, windmills, 3, solar, hydropower, and wind. It does not need any, sun is giving us light full day. Do you pay any money to sun? But if you will use 100 watt, 10 watt LED lamp bulbs, your electricity bill comes. But sun is giving you light day and night. In daytime here, nighttime it will be daytime somewhere else. Do you pay energy bill to sun? Why you are not using? You are using fan. But when there is a wind, are you paying for that wind? Oh, बहुत अच्छी हवा चल रही है. Do you pay? No. So it's nature's gift. Hydropower, you drink water. You will go to a fountain. You'll, oh, very nice. I'm getting fountain water. It looks, if you any garden, you go, you will find fountain. You start living over there close to the fountain. You enjoy for it. Nature, it is raining. Do you pay for it? No. So we have to go for renewable source of energy and reduce the fossil fuel. 3 things: solar, wind, and hydropower. Right? Energy efficiency. How? We have to go for green buildings. Green buildings means what? We have to have renewable source of energy. We have to have a waste management. Whatever waste is coming, generate energy from that. Whatever human waste are going, human waste excrete, urine, generate energy from that. STP. You recycle, reuse, use it, that water for treated water for gardening. So improve the energy efficiency. Use renewable energy. Modernize infrastructure, green building, as I told you. So we have to have power lines, pipelines, and everywhere we need to really work hard. Cables, earlier we used to have high voltage, high power cables were going, lot of energy were lost because someone is going close to that high tension wire, they will just go and stick on that. They will die because it was having lot of area which was having the magnetic effect, electrical effect, and that was creating problem. Ensure energy equity. You are finding those who are not getting, cost is very high, they are using illegal way of making the energy, using it. So make it proper. We can use local infrastructure, and these are some of the things I think if you are able to do only one, that is renewable source of energy, all the 3 second one is the infrastructure development, local development. We reduce the expenses, we reduce the energy, electricity or the fossil fuels by having the local infrastructure, or third one is the green building. So these 3 things if we are doing, one is the renewable source of energy, it has 3 components: solar, wind, and solar, then the wind. Third one was hydropower. That is one thing, we reduce it. Second thing, we can use local material, local mechanism, so that we can reduce the use of electricity, transportation, fuel, and everything. Right? And what was the third one? We can really look for the how we can make it more efficient buildings, green buildings. So in a structure, 2 things. One is the green building, another one is the local material you use, and third one is the use renewable source of energy. So this will really reduce its impact on the climate change, and it will really give you you can make a good connect between the climate change and energy efficiency. The topic was very relevant for today's, and I would like to thank each of you who were here and who listened my talk. It was really wonderful. These are some of the things. Germany, they have done a lot of work on this. They have done. In India also, we are coming up, and I am expecting that each of us can really do it. So, so many things which are in addition to what I discussed now, that we can go for our governance, health, education, demographic, and everything we can really think of that. So now I am going to end up. I have done so many projects with international people. I got ASC awards and all. These are the things which are I have done so many projects in India as well. I'm involved in, and then these are the my news. I'm coming frequently in the news for live programs, so some of you can also join sometimes. So that's all about my talk, and if you have any question, please ask me. Feel free to ask me the questions. Yes, please. Fatima, I am, I think, done. Any of you have any question? I'm finding good number of people joining here. So if any of you have,
Dear participants, if you have any queries, you can please ask your questions.
many participants are giving thanks to me in the chat box. But no one is asking any question to me. I think either they have understood fully or they have not understood.
No, so it was very engaging and interesting session. Once again, request the participants, if anyone would like to ask any question, so is ready to answer.
Okay.
So we'll take it as no questions then.
Yeah, thank you. Thank you. Okay. So should I close now?
Just a minute, sir. Let me check. So once again, good evening to one and all. As we come to the end of this insightful and thought-provoking session on climate change and energy management, it's my honor and privilege to propose a vote of thanks to our esteemed speaker, Professor Jan. On behalf of Maulana Azad National Urdu University and the organizing team of this faculty development program, and all the participants, I extend our deepest gratitude to Professor Jha for delivering such an enlightening session. His deep knowledge with decades of experience in the fields of water source management, climate change, and sustainability has given us a fresh perspective on the climate critical challenges and opportunities surrounding climatic change and energy management. We are immensely grateful to you, sir, for sparing your valuable time to be with us today and sharing your expertise. Your session has not only explained our understanding, but also has motivated us to take proactive steps towards a more sustainable and resilient future. Once again, I thank you so much, Professor Jha, for your invaluable contribution. We look forward to having you with us again in the future. Thank you, sir. Thank you so much.
Thank you. Thank you so much. Thank you so much. Okay.
Dear participants, we'll have a break of about 5 minutes. Then we'll join for the next session in another 5 minutes.
Remember, we have deleted our select.
I shall move.
Yes. Hello, everyone. Can you guys hear me?
ऐनक लगाऊं?
So yeah, if I got a green light that everybody can hear me, so, are we good to start?
Good evening, sir.
A very good evening. Yes, Madam Hajaranga. Can you hear me?
Yes, sir.
Yes, madam. Whenever you're ready.
To the participants, sir, then we can start. Yeah, participants. The speaker, the resource person for the session 2 of FDP of today's session is Mr. Jawad, Mr. Mohammed Abdul Jawad. He is a CEO of High Octanes Lab Private Limited, Hyderabad, as well as Embedcom Technologies, Canada. Mr. Jawad has a degree in BTech in Electronics and Communication and MS degree from Germany in IT and Automation Systems. Mr. Jawad has over 2 decades of experience in designing embedded systems solutions in the fields of automobile, oil and gas, and industrial controls. His work contributed in building IEC standards and solutions globally implemented, smart meters, AMI, etc., creating innovative ecosystems for industry and research, excelling in embedded systems. He is currently designing products for remote monitoring and control for predictive maintenance, creating digital twin. Now I request Mr. Jawad to take over the sessions.
Hello, everyone. Assalamu alaikum. Good evening. So, yeah, thanks for the warm welcome. So, yeah, before I start, I would like to, thank the platforms in which, it is encouraged for faculty development programs are done so that there is a connect between the industry and the academy. So this was a passion, after my education, I wanted to bridge that gap. And there's a reason you see me here. And I really thank the ATAL platform and the Manu management for having me and inviting me for this session. So yeah, so here I'll try my best to show present what the industry is currently doing in this arena. And of course, let me share my screen. Let me see my screen. Let me see. So, can you guys see my screen? Any one participant, Madam Hajara, can you see my?
Yes, sir.
Yeah.
Yes, sir.
Great, great. So, well, as Madam mentioned, one of the companies I'm running is Embedcom Technologies. So we are more into green solutions, where we, kind of develop products to preserve the natural resources and to make optimum use of energy. So we are into that part. So of course, sustainable urban energy planning encompasses a lot of things. So Embedcom Technologies touches a couple of them, which I'll of course emphasize on what on how we are trying to support this entire ecosystem, and not least the upcoming smart cities, how they are planned, and what Embedcom Technologies' role is in developing those smart cities. So let's get started. So yeah, so what overall what we would like to here represent is the sustainable urban energy planning. Of course, as per the definition, we kind of determine the strategies to manage the generation part and the consumption part. So of course, I'm not much into the generation part, but of course there are tons of information available. There is plenty of work done by various institutes on that part. So I kind of stole the data from them, courtesy on their courtesy, and then we are mostly involved in the optimization on consumption part. So emphasis will be given on consumption, but of course I present how generation is done in the current generation. So what's the whole goal over here? Here is to reduce environmental impact and increase energy efficiency, and of course to secure the energy for generations to come. What we will be focusing in this presentation is energy efficiency, renewable energy integration. Once we have that renewable energy, how will we integrate in our existing platforms? And the smart grid technologies, what technologies are we using to use the energy efficiently? So that's the smart grid technology, what we are actively involved in currently. And sustainable transportation, we are not much involved in this, but of course there are lots of development going on for transportation. I'll give you with some case studies of which country is doing what in that aspect. And then last but not least is this energy storage, how we can store this energy and so on. So yeah, let's get started. So what's the problem? So we know that I bet you guys have heard about greenhouse gases. So we are the culprits for them, and a human being, because of its greed and pulling more than required. So we are creating some unwanted atmosphere within our planet, and then we have, of course, it comes with some cost. So once this gases are emitted, and undesirable gases, what we already know, it's CO2, it's methane, it's nitrogen dioxide, and there are tons of fluoric gases released in the atmosphere. So what's the problem with this? So the problem is, once these gases are emitted, then the atmosphere has those a layer is created, and which the energy which comes from the sun, heat energy, is being absorbed on the outer layer of the atmosphere, and they are not emitted in the space. So there is effect of heat. Of course, in the next slide, I'll elaborate on what different areas these affect our Earth in all. So the basic reason is to control these emissions, greenhouse gases. So I want to emphasize on this slide, just because we know what we are targeting, and how countries are collaborating to reduce these greenhouse gases. So, of course, to know what are the sources of these gases are power plants. When I say power plants, I mean when you generate electricity. So you use fossil fuel to generate electricity, and because there is a huge demand, and once you generate that amount of gigatons of wattage, there is an emission, and that emission is irreversible, and that is affecting the entire greenhouse gas emission. So power plants is one of the major things. The other one, of course, we know, is the pollution from the vehicles, and of course the manufacturing industry. You name it, all kinds of manufacturing industries, the commercial and residential buildings, agriculture, and the expansion of the land use in the urban areas, and removal of the forestry. So these are the causes for our greenhouse gases. So coming to the next slide, I think is the continuation of the problem statement. So now, once we have these unwanted gases, what's the impact for that? So the impact on them is, of course, we thought it was a myth, but now there is an evidence that the temperature is rising. So we see that heat in the atmosphere that's leading to global temperatures. So now what happens because of that is, of course, it's an ecosystem. So one thing is disrupted, everything gets affected. So what are the effects? It's climate change. So we see increased greenhouse gases cause shifts in weather patterns, including more extreme temperatures, storms, and droughts. And we have the melting ice caps, which normally you see in polar icebergs. They are melting, and the result of that is the rise in the sea levels. And so the next is the acidification of the ocean. So higher CO2 levels lead to more CO2 being absorbed by oceans, making them more acidic and harming the ocean life. So the next one is the disruption of ecosystems. So altered temperatures and weather patterns can affect biodiversity and disrupt ecosystem. Of course, we have because everything is interconnected and not isolated with each other. So it's the ecosystem will be gets affected by this. I'm not sure whether I pulled the slide for number of deaths happening because of the atmosphere, but yeah, there was a statistics that shows how many deaths are happening just because of the polluted gases. So here, higher temperatures, air pollution, this could lead to respiratory problems for human being and heart-related issues and spread of diseases. So yeah, so there is a very interesting study done on this. Besides accidents happening by transportation and so on, there is a statistics present to show the evidence for that. Agriculture, yeah. So India plays a lot of role in this agriculture. The ways we are using and to do the agriculture that can changes in the rainfall and temperature patterns affect crop yields and food security. So these are the effects of the fundamental emission of greenhouse gases. Moving on to the next slide. So yeah, so now in other terms, we call that carbon footprint. So we encourage the companies, manufacturing industry to have as less as possible the carbon footprint for whatever they are producing. So a carbon footprint measures the, so what's the definition? Let's say the definition is the total amount of, how do you, there should be a KPI for that. Yeah, you should measure that. It should be measurable, right? So so if the measure is of course the gases. So out of the CO2, methane, nitrous oxide, how are we measuring? So important part is of course the carbon dioxide, CO2, and of course we know there is a methane as well. But our emphasis in I think this is the 70% of the entire greenhouse gases. So we express that in the equivalent of tons of CO2. So yeah, so this is a basic definition of the carbon footprint on that part. And coming to the statistics of the globally, what are the rates? So I tried to pull the latest information on this. I don't recall exactly. It's a World Bank for data on GHC. So what we have seen here is, as you can see, as I have mentioned, the yellow part is the power industry. So this is the major contributor of greenhouse gases, and the other one is the manufacturing, where you have lots of unwanted gases being released in the atmosphere, and there is in transportation we have aviation, and so on. So agriculture is not least. So these are the statistics, and you can see a small dip in 2020. I guess you know why this dip is. I think you guys can guess on that. So there was pandemic, so we saw the dip in that. So there is an evidence that, I mean, if we burn less, then the environment is being secured. So yeah. So right now we are sitting somewhere in 53 gigatons, 53 gigatons of CO2 equivalent. Okay, this is global. So now I thought let's, because we are sitting in India and we know what India is playing, a huge role in contributing to this. So in India, there was a study conducted by the same institute, and they have given us the statistics for all the countries. And I pulled the the chart for India, and again it says the major is coming from power industry, and then we have other manufacturing industries, and not least agriculture. So yeah, out of the in all the gases I have shown in the earlier slides, there were CO2 and nitrogen dioxide, methane. So the major contribution is from CO2, and the second biggest culprit is methane. Yeah. So yeah. So by the way, you guys can simply interrupt me if you have any questions or if it is not clear. So yeah, I can simply stop and then answer your question, or you can do that after the end of the session as well. So now we know the problem, we know the statistics. Lots of companies have contributed in getting the data, and we understand the problem. So now, what's the solution? So some some countries came together and they said, let's try to work to reduce these emissions. So there was a Paris Agreement, which is it's a global treaty under UNFCCC to combat this climate change, limiting global warming, of course. And what does that mean? Is to not have the temperature rise below 2 degrees. So so this was the aim. That we have to get our atmosphere as good as it was in 1800s to 1900s approximately. So yeah, so what is required in that? It requires countries to submit nationally determined contributions, update them every 5 years, and strengthen climate resilience. So this was the mandate given whoever was into this agreement, and many countries participated, including India. I'm showing further slides, what are their promises and what are the numbers. So now, developed nations pledge the 100 billion annually to support developing countries, but of course there was a shortfall on the contributions, and there is some hiccups in achieving the targets, but still they did not give up, and the countries are still working towards that. So here we go with the Paris Agreement, and let's see what's coming up. So now, so yeah, so coming back to our main goals, what we have started with. So we understood the problem statement. We understood what the countries are trying to do to solve the problem, and now let's highlight on some of the aspects what is practically being done. So the first thing is renewable energy integration. Of course, once you have that energy, how will you integrate with the existing infrastructure? So I slightly touched on highlights the use of solar, wind, and geothermal energy in this, and then in energy efficiency, which is again a priority, because if you remove efficiency, then what all we are producing is wasted. And we have seen with evidence that if we develop an efficient system, 40% of the energy could be preserved. So when I say preserve, you need not generate that. So it's kind of supply demand study. So 40% is not a less number. So what does efficiency focus? It focuses on improving building designs, utilizing district heating, and adopting energy efficient appliances. Because we are into embedded systems, electronics, and mechanical, so we kind of try to provide solutions in which the appliances they use less energy and they do the same amount of work. So yeah, we got a quite good hold of developing or getting a statistics on the applications. Yeah, there are various applications like HVAC system, and there are smart grid, in oil and gas, automotive industry, and yeah, so there are lots of applications for that. Now, coming to the urban form and land use. So here the idea is to promote compact, well-planned spaces to minimize energy consumption, so that if there is new development, so we can plan ahead how the infrastructure can be planned, so the energy will be used optimally. Next is the smart grid technologies. As I mentioned, embedded technology is quite ahead in this sector, and this involves real-time energy distribution and effective demand management to optimize energy use. And yeah, so again, it's about this study of supply and demand to match them and use it efficiently. Sustainable transport, it encourages adoption of electric vehicles. I think you guys have already seen on the streets, we see the electric vehicles, and so we have less emissions, enhanced public transportation, and many countries adopted the cycling to reduce emissions. Yeah, this keeps us healthy as well. Yeah. So not least energy storage. So we emphasize the importance of technologies like batteries and pumped hydro storage for storing renewable energy. So we will kind of, the next slides, we'll try to focus on these elements of what I have briefed up, and of course you guys can stop me or question me if you have any questions on that. So a quick again on how we can efficiently use the energy. So this is one of the important studies and analytics of what's the demand of the humans on energy part. So what does it do? It refers to using less energy to perform the same task or achieve the same outcomes. It involves optimizing energy use across various sectors. So we know it's transportation, industry, buildings, appliances, by adopting technologies, practices, and behaviors that reduce energy waste. This is very important, right? So we have to reduce the wastages. So how can we do that? Building insulating homes, using energy efficient appliances, and implementing smart energy management system. This is one of the biggest things what major companies are working towards that. Transportation, improving vehicle fuel efficiency, transition to electric vehicles, and using public transport or shared mobility. So we have lots of countries stepping up to solve the transportation issue and using it in an optimal way. Industry. So using advanced technologies and processes that require less energy for production, such as efficient motors and heat recovery systems. So next one is the renewable energy integration, increasing the use of solar, wind, and hydropower to provide clean energy, reducing reliance on fossil fuels. So maybe I did not use it was earlier, but the whole thing is happening because of the current use of fossil fuels, because this is irreversible, this is non-renewable energy. So this is what we want to get rid of, right? So next is now we're focusing on actual. This is the absolute solution the world is moving on. So what is that? Is the renewable energy. So renewable energy is the energy that comes from the source that won't run out. These sources are abundant and sustainable, making them the key to reducing greenhouse emissions and combating climate change. So yeah, so we love this method. We want to go for this because it affects less on the planet, healthy living, and so on. But we have to do a little sacrifice for that of using our resources in an efficient way, on an optimal way. So major types of renewable energy include solar. We heard of that. Yes, converting the sunlight to electricity. We have wind energy. We have hydropower. We have geothermal energy. That is, of course, heat extracted from beneath the Earth's surface. We saw the use cases of hot springs. I'm not sure whether I included a slide on this, but yeah, they are literally hot springs coming out of the Earth, and we can make use of them. Biomass is not least energy from organic materials like wood, crops, or waste. So yeah, these are our ideal sources of, or should be, what we are currently working on to generate the energy instead of using fossil fuels. So we don't want to use fossil fuels because it's irreversible, it's non-renewable energy, and we want to avoid that and move to the renewable form, which is the 5 forms what you see on the screen. Okay, so advantages of renewable energy includes this low environmental impact, infinity supply and potential for local energy production. Challenges involve initial setup costs, variability of sources like solar and wind, and the need for technological advancement in storage and grid integration. Of course, if I want to have my electricity bills reduced a little bit, then if I plan for a solar on my rooftop, then there will be an initial investment. But that initial investment, which ROI, what do you call that, and that could be regained, if not in few months, but in few years. That cost will be easily, regained. So yeah, there is of course an initial, setup cost for these kinds of, ways to generate the energy what we are willing to use, which is electricity, for example. So yeah, what comes next is very interesting topic is smart grid technology. Of course, this is our subject. What Embed Technologies is deep into this, but of course, I did not put tons of slides for that. I would love to answer any questions on this. So yeah, so the other way to, okay, once we produce energy, so how to use it? I mean, now we have plenty of them. Can we use it as we wish? No. So we need to find out how much we actually need, right? So we have smart sensors, smart meters. We have tons of ways to determine what's our requirement, what's the demand. So once we know the demand, then we can alter the production part. So yeah, so smart grid technology is a collection of advanced technology that use digital communication and intelligent devices to monitor and manage the electricity distribution network. So when we say two-way communication, that means that not only the consumption is controlled, but also generation is controlled. Smart grids use two-way communication to allow for the flow of electricity and information in both directions. So that's the reason we use demand and supply will be kind of a closed loop is happening here to determine when to generate as per the demand. So real-time data, smart grid uses sensors and automation to collect real-time data, energy usage, and grid conditions. So smart meters, we already see smart meters in our homes that logs tons of data to measure. Everybody in the evening they start using all their appliances like washing machine and their what do you call that, stuffs which run on electricity, and the consumption is huge in the peak hours, maybe 7 a.m. to 9 a.m. and then in the evening, and in the afternoon it's almost idle, sitting at nothing, bare minimum consumption. So to optimize this peak hours, once we know the statistics, then the supply could be managed. So renewable integration is the smart grids can integrate large-scale renewable energy sources like wind and solar. And then we have the demand response. Smart grid can use demand response to manage electricity demand. Is what I was mentioning. Okay, so let's see what comes next. Now comes the transportation part. Very interesting part. So we have been looking into the transportation since decades, and we have seen, now, if you go on the streets, you have to put the masses. Example in New Delhi, you simply cannot, walk on the street, and if a person is already have respiratory problems, he cannot walk on the street in New Delhi. Thanks to still we are in the south part here in Hyderabad. Still we don't see the worst case, but this is one of the important things. But if we don't take control of this now, then we could face similar issues in the future. So what is expected out of this transportation is a sustainable transport system. Refers to a transportation network that meets the mobility needs of people and businesses while minimizing environmental impacts, conserving resources, and promoting social equity. So what are the key components for this? Is public transport. So we have the public transport we see powered by clean energy. I think I'm not sure whether we see that here, but in Europe definitely they have already stepped into it, and we see the trains and trams being powered by electricity. Powered by batteries. So now comes the active transfer promotes. This is again normally we don't see that here in India again, but in European countries they have made a special dedicated lanes for bikers and pedestrians. So the infrastructure is very friendly for them, and they can commute to one place to other, and it's healthy as well. And the other one is the electric EVs. I think it's already in action. So we see electric vehicles on the road, and this, of course, will reduce the emissions as compared to burning the fossil fuels, what we have already seen in the past. So yeah, countries are increasing their EV charging infrastructure and offering intensive EV adoption. It's true. Yeah. So shared mobility is car sharing, bike sharing programs, reduce the number of private vehicles on the road, easing congestion and lowering pollution. And these systems provide flexible, cost-effective options for urban residents. So yeah, it's a culture in some countries that you go from one place to other place, and they simply put in some platform or group that some has to share a ride from this place to this place, and the guy simply says, yes, I'm available, and they can simply share the ride. Okay, so now comes the integrated transport system, a seamless and interconnected network of public transit and cycling lanes, EV infrastructure, and walking pathways, as I mentioned earlier, helps improve accessibility and reduces the need for private car use. So this was for the transportation. I think in next slides you might see some examples, but let's see. Yeah, I think it's continued. Yeah. So some examples I try to pull from different countries. So we have seen electric buses, autonomous vehicles, and smart traffic management system can help optimize routes, reduce congestion, and improve air quality. So it's not just coming up with a generating a renewable energy from wind or hydro, but it's about how you use it. If you use it efficiently, if you have a smart city built efficiently, then you can kind of utilize that in a better way. So technology like ride-sharing apps and mobility as a service platform allows us to can adopt on this platforms and reduce on the GHS. Next, transit-oriented development is promotes higher density mixed use developments near public transport hubs, reducing the need for long car commutes. Okay, so this again kind of organizing the transportation, designing cities to prioritize walking, cycling, and public transport over private vehicles. So now we have the examples of sustainable transport system. So again, as I mentioned, Europe is quite ahead in this aspect, and in Denmark, so known for its existing cycling infrastructure with more than 390 kilometers of dedicated bike lanes, making cycling the preferred mode of transport for many residents. So yeah, so this is very intensive way and to stay healthy as well. The city has electric buses and aims to have carbon neutral transportation by 2030. So that was Copenhagen, Denmark. So Netherlands is again a very intelligent step of taking into cycling with around 38% of all trips made by bike. This is a huge number, 38%. The city has electric trams and aims to transition zero emission public transportation by 2025. So we are into it. I did not get the update for that. Let's see what happens. So next slide is storage. So in the storage part, we have the, of course, we have seen the lithium battery in the market, and we can use in large scale to store the energy what we are generating. So why do we need to store? So it's simple, yeah, right? So on the peak demand, we need not generate that amount of energy, and we can use it from the stored resources. So the other types are solid state batteries and the flow batteries, where is solid state battery, new technology with higher energy density and improved safety compared to lithium ion. And the flow batteries is more towards liquid electrolytes to store and release energy. So coming to the pumped hydro storage. So water is pumped to a higher elevation during low demand and released to generate electricity when demand is high. It is most widely used large-scale energy storage method. So I'm not sure whether I pulled some use cases, but this is also one of the efficient ways to for storage of the energy. So compressed air energy storage is air is compressed and stored in underground caverns or containers during low demand and then released to generate power during high demand. Compressed air energy. Thermal storage, a molten salt storage used in solar power plant. It stores heat generated during the day and releases it to produce electricity at night or during cloudy weather. Ice storage is used in cooling systems, of course, to store ice during off-peak hours and use it for cooling when energy demand is higher. So why do we need to store? Of course, we need the grid stability, so that when the demand is high, we are not putting complete load on the grid, but on the generation part, but we can also use it from the stored energy. Helps balance supply and demand, ensuring consistent electricity supply. So renewable energy integration is the important part. Stores excess energy from renewable sources for later use, enabling a higher share of clean energy in the grid. So cost saving optimizes energy usage and reduces the need for expensive peak demand power plants. So yeah, of course, if we of course, it's common sense that if we happen to store that energy and during the high demand, we don't need one more plant to produce the required power for that demand period. So this is kind of very easy way if we kind of store the energy in the methods I just mentioned. So yeah, the future is going towards smart cities. Everybody wants to live in convenience and with pay less bills. Of course, we'll pay less bills if we use less energy efficiently, and and all city is the ecosystem is developed to somebody wants to in the ambulance, they take forever to reach the emergency the patient in emergency. So everything will be interconnected, and the livelihood will increase with smart cities. It's not just conveniences. We not only reduce the gases, but our livelihood will be improved as well. So definition of cities that use digital technologies and data to improve the quality of life. Of course, what I mentioned, quality of life is important. This is the final target. Increase efficiency and promote sustainability. So we don't want to use everything and leave nothing for the coming generations. So what do smart cities do? So you heard of Internet of Things. So we hook up sensors in almost all the infrastructure to get the data. Once you have the data, then you can make decisions on that. So data is the new oil. So connected devices for city management, like for example, traffic, as I just mentioned. Imagine a ambulance never has to face a traffic signal. So it's green, green, green for ambulance. Imagine that system. So for that, we need to have the devices connected to each other to manage that ambulance, take its optimal route to go to its destination. Data analytics, real-time data for decision making optimization. I think you heard of artificial intelligence and machine learning. So we can make use of those for data analytics. Smart infrastructure, energy efficient buildings, smart street lightings, intelligent transport systems will be effective for using the energy efficiently a digital platform for residents to participate and interact, to share their complaints and so on, so they can let the authorities know what problems they are facing, and then two-way communication can resolve lots of problems. Sustainability, reduce carbon footprint, renewable energy, waste management, as I mentioned. We don't want to leave the bad world for the upcoming generation. Resiliency systems to anticipate and respond to climate changes. So this was with the smart cities. Let's see what's coming up. So now, how can we link the sustainable energy to the smart cities? So now we have to integrate the two parts. So ASEMEP provides the energy framework for sustainable urban development, and smart city technologies enable the efficient use of energy and data-driven solutions. So integration is the smart grid is what I emphasized on, is how demand and supply could be managed well. That could only happen if you have enough data to analyze, and then you can produce the appropriate amount of energy. The smart grid is one thing. Renewable energy systems are integrated into urban infrastructure, of course. Yeah, energy efficient transportation and building system are enhanced by technology. So the measures what we have seen in the transportation and the building systems, not least, and use of technology. So it's an ecosystem. So only one aspect will not be enough to drive this or make this happen. Okay, so what we have concluded in the entire, I guess, 45 minutes is here. The renewable energy and smart cities are crucial for developing sustainable, energy efficient, and livable urban spaces. Combining smart technologies with sustainable energy planning enables cities to tackle modern challenges like climate change, pollution, and resource depletion. We have learned this. So what's the goal? Create cities that are technologically advanced, environmentally friendly, and resilient for future generations. So this is our entire aim, is to, of course, reduce the use of fossil fuels, thereby affecting or reducing greenhouse gases emissions, CO2, and the effects, so forth, and developing smart technologies to use the energy generated in a sustainable way, and of course use it efficiently. So this is the complete ecosystem what we have concluded. Any questions so far? No comments, then I will proceed with the next slides. So I don't see any hands raising. Okay. Okay, so now nations working towards this. So I put some use cases, the practical what countries are currently contributing to that. Hopefully the next 15 to 20 minutes, I think I can discuss on this. So what countries have promised as part of the global efforts to reduce the carbon emissions. So countries have established limits for targets through agreements like Paris Agreement, aiming to keep global warming below 2 degrees, ideally 1.5 degrees centigrade. Yes, these targets vary widely. So now we have European Union. So the European Union has grouped together as Europe, reduce emissions by 55% by 2030 compared to 1990 levels. So we are comparing always with pre-industry era. So because we think that after the industry era we have polluted enough, so we kind of go back to that era, and we have to achieve that 55% by 2030, achieve net zero by 2050. This is a big achievement. So yeah, so let's see. Carbon market, the EU emission trading system caps emission for industry. So yeah, they will cap the emissions for the industries. The more you have the carbon footprint, the more will you be taxed. So United States target reduce emissions by 50 to 52% by 2030 compared to 2005 levels, achieve net target by 2050. Policies include incentives for renewable energy and electric vehicles under the Inflation Reduction Act. So they have created their own incentives, ways or encouraging the citizens to how they can move to renewable energy. For example, that you can use solar panels in your homes and use electric vehicles, and they will be given with incentives. China, peak emissions by 2030 and achieve carbon neutrality by 2060. So China is the world's largest emitter, but heavily invests in renewable energy. I think I'm not sure country-wise did I include the chart. We have seen China in the chart is the one which produces the most, and then I think US or India, something like that. Yeah, India contributes approximately 7.5% of the global emission. So continue. Let's continue the limits by major countries. So India reduce emissions. The target is intensity of GDP by 45% by 2030 from 2005 levels and achieve net zero by 2070. Focuses on renewable energy expansion and afforestation, plantation. India focuses on lots of plantation. So that is one way it is planning to reduce the greenhouse gas emissions. Canada is, reduce emissions by 40 to 45% by 2030 compared to 2005 levels, achieve net zero by 2050. Implements a national carbon pricing system. Australia, similar 43% by 2030 compared to 2005 levels and net zero by 2050. And renewable energy policies are a primary focus. Renewable energy policies, yeah, what we have spoken about, I think the wind, I guess. We'll see in the next slides maybe for Australia. So Japan reduce emissions by 46% by 2030 and compared to 2013 levels, net zero by 2050, prioritizes hydrogen energy and carbon capture technologies. So now there are some countries, I have pulled the data on what the other countries have achieved so that India can adopt similar but the use cases what we see in the existing success stories. So it's Finland, smart energy solutions and carbon neutrality is smart district energy. Helsinki is working on a smart district energy system where buildings and energy system communicate with each other to optimize heating, cooling, and energy usage. The system is integrated to renewable energy sources to reduce carbon emissions. Carbon neutral city, again, Helsinki aims to be carbon neutral by 2035. To achieve this, the city's transition to renewable energy, improving energy efficiency and promoting electric mobility. So smart water and waste management. Helsinki also uses smart systems to monitor water and waste, optimizing the use of resources and reducing energy incentive waste treatment process. So yeah, water is not least, I have seen water meters, but in India still they did not, monitor the actual consumption. They put a cap on the extraction of underground water, but they actually don't, regulate it. So yeah, but in other countries they have their, like we have, the electricity meter, they have the water meter being built every month. So here, of course, we have the meter, but I'm not sure. It's not as active as we have in European countries. Yeah, India is very, of course, active in electricity part. If you don't pay the bill, within, I think, 2 to 3 weeks, the electricity will be disconnected. But that's not true for water. Okay, so next is Singapore. Smart water management and energy efficiency. So smart water management, Singapore uses a smart water management system to monitor and optimize water usage across the city. Sensors track water consumption, as I mentioned, it's very important, in real time, and the data is used to manage resources more efficiently and reduce waste. Solar energy, Singapore has also invested heavily on solar energy, installing solar panels on rooftops and integrating them into the power grid to promote renewable energy usage. Green buildings, the city promotes green building standards through the BCA Green Mark certification, encouraging buildings to adopt energy efficient technologies such as solar powered water heaters and smart lighting systems. Not least smart lighting systems, it's all automated. I mean, if you don't use it, it shuts off on its own using, advanced sensor systems and so on. So yeah, so next will be Amsterdam, Netherlands, circular economy and smart infrastructure. So circular economy, Amsterdam is working towards becoming a circular city, focusing on reducing waste and promoting recycling and reusing materials. The city encourages businesses to implement circular practices where products are designed for reuse and recycling, minimizing energy waste. So smart energy meters, as I mentioned earlier, in smart cities, Amsterdam has implemented smart meters across households and businesses, allowing consumers to track their energy usage and adjust their behavior to reduce consumption. I don't think so. I've seen tariffs. So normally in demand period, for example, as I mentioned, in the morning or the evening, the tariff is different to the non-demand period. So people are encouraged to use the washing machines and this in the afternoon session as compared to evening or early morning sessions. So the government is trying to control them by putting tariffs. I don't think so. I've seen again in India. India is putting smart meters into places. So soon we will see the tariffs here as well. That means they will measure the demand and they will encourage to distribute the demand. They will put high rate on these particular demand periods and less on that. So to balance the consumption. Renewable energy and electric mobility. The city is heavily invested in electric mobility with an extensive network of EV charging stations and incentives for electric vehicles use. Amsterdam is also deploying a solar panel for public buildings and private homes to reduce reliance on fossil fuels. So here was Amsterdam, and next comes Barcelona, Spain, the smart grids and renewable energy integration. Smart grid energy. Barcelona has implemented an advanced smart grid that allows for real-time energy monitoring and management. This helps optimize energy distribution, reduce losses, and ensure efficient use of it. Of course, what we spoke about, using the energy efficiently. We need an advanced system to close the demand and supply channel. So it's a feedback control system. So feedback control system always helps to control our usage. Renewable energy integration. The city has integrated solar panels, wind energy into its infrastructure. Many public buildings and streets are powered by solar energy, helping reduce reliance on non-renewable sources. So that's our final target, is to ditch the fossil fuel usage in generating the power. So energy efficiency in buildings. Barcelona has implemented smart building system that use sensors to monitor and control energy use for heating, cooling, and lighting, thus reducing energy consumption. So we have already discussed about that. So this has been practically done in Spain, Barcelona. So next slide is about Denmark. So what do they do? Goal is carbon neutrality by 2050. Actions that Denmark has been a leader in wind energy with over 50% of electricity now generated from wind power as of 2023. The Copenhagen's climate plan aims for 70% reduction in CO2 emissions by 2030 compared to 1990 levels. So results in 2021, Denmark's renewable energy share in total emission was about 38%. That's great achievement. Okay, so next comes the Sweden. So net zero emission by 2025. So Action Sweden is investing heavily in renewable energy, especially hydroelectric, wind and solar power. Carbon tax and subsidies for electric vehicles are central for Sweden's strategy. So yeah, you tax them so that they move to electric vehicles, and you pay them intensive. That's the best way to optimize or show the citizens the directions to have less emissions. Results: Sweden reduces its CO2 emissions by 25% between 1990 and 2019, despite growing GDP. It's awesome, great. Over half of Sweden's electricity comes from renewable sources, with hydropower and wind being the largest contributors. Hope India will also achieve, because it's working hard towards that. So now comes the Costa Rica. We have carbon neutrality by 2050. Actions: Costa Rica relies heavily on renewable energy, especially hydropower, wind, and geothermal energy. It has become a global leader in sustainable tourism and forest conservation. Results is 2020, Costa Rica produced about 99% of its electricity from renewable sources. The country has reported over 2.5 million hectares of tropical forests, helping to offset carbon emissions. Wow, this is great achievement, right? So I think India is in line with this. India is also kind of restoring so now comes the Germany part. Somebody has to mute their microphone, I guess. Anyway, so Germany, we have carbon neutrality by 2050. Actions: Germany has been at the forefront of the energy Wende in national policy, focusing on transitioning to renewable energy, improving efficiency, and reducing nuclear power. The country has set ambitions, renewable energy targeting, including increasing wind and solar power capacity. So we have seen most of the countries are moving towards wind, hydropower, and solar. So Germany is currently the fourth largest producer of wind power globally. So 45% of its electricity comes from renewable sources in 2020, with solar and wind contributing a large share. So that was Germany. I think that was my last slide. So yeah, so what do we conclude here is to get rid of fossil fuel, we need electricity. We cannot get rid of electricity. We need generation part. We have to change. And generation part we have to change by using renewable sources. And once we generate that, it's not enough. We have to plan to use it efficiently as well, by having smart cities, plan the infrastructure, and use technologies to use the energy efficiently. So this year I conclude my presentation. If there is any questions, you're most welcome to ask. Yeah, I would stop my slide presentation, and we can have open discussion if you like. Madam Hajira, to you. Yes, Madam Hajira, are you with me?
Once again, good evening to all participants. As we conclude with this enriching session on sustainable urban energy planning and smart cities, it's my privilege to extend a heartfelt vote of thanks to our distinguished speaker, Mr. Mohammad Abdul Jawad. On behalf of Maulana Azad National Urdu University and the organizing committee of the Faculty Development Program, I would like to express our deepest gratitude to Mr. Jawad for sharing his profound insights into one of the most critical challenges of our time, integrating sustainable energy solutions into urban planning while leveraging smart technologies for building the cities of the future. Exploring advanced energy systems to understanding the role of smart technologies. His talk has equipped us with actionable strategies that we can adapt in our respective domains. Second, I thank Mr. Jawad for your invaluable insights, and we sincerely hope to have you with us again in the future for more such inspiring sessions, sir. And thank you so much. And thank you all participants for your patient listening and active participation. Now I request the participants to fill the attendance cum feedback form before leaving the session, and we'll end the meeting here. Thank you, sir, and thank you all participants.
Thank you again, everyone. Thanks for your comments. It was great having you guys see you. Thanks, everyone. Take care. Bye.